Chapter 4, we will be studying trigonometry. Trigonometry is studying the measurements of triangles, so kind of their angles, their sides. 4.1 is introducing some terminology and conventions used when studying trigonometry. Okay, you have looked at angles before. You can see these two angles, they appear similar. In this chapter, the angles can be positive or negative. If they are positive, they're going to go in a counterclockwise direction. So for this to be positive, there needs to be an arrow indicating its direction. Okay, if that's positive, this is called the initial side. Up here is called the terminal side. Okay, and that's because for the direction it starts here and it heads up in this direction. The corner of the angle is just like when you learned it in geometry, it's still called the vertex. Okay, so for the next angle, if we are to assume that this is actually a negative angle, then it has to be going in this direction. Okay, and the direction does matter very much in this chapter. Now this is the initial side, and then this would be the terminal side. The vertex is still at the corner. Okay, so for an angle to be in standard position, it means the vertex of the angle is at 0, 0. The initial side is the positive x-axis, so the angle would have to start from here. And then it could go in either the positive or the negative direction depending on the angle. So if it was an angle like this, it starts from the initial side at the positive x-axis and it would be going this way. This would be a positive angle. Okay, almost everything in here is going to be in standard position, so always assume the vertex is at 0, 0, and it always starts from the positive x-axis as we measure. Although we will be using some degrees this chapter, we will mostly be using radians as our unit of measurement for angles. The main thing to remember that pi radians represents the angle measurement of half a circle, or 180 degrees. 2 pi radians represents a full circle, or 360 degrees. As long as you can remember one of those things, you'll be able to make appropriate deductions from there. For the first example, I'm going to sketch these angles in standard position on these graphs. Okay, let's see, standard position means the vertex is at 0, 0, and it has to start from the initial side, which is the positive x-axis. 45 degrees, let's see, the vertical line is 90 degrees, so 45 degrees is about halfway. Okay, because this is positive 45 degrees, you have to indicate that it is positive by using an arrow. Now this represents positive 45 degrees. For B, we're going to graph negative 100 degrees. Okay, again, always start vertex here, positive x-axis. Because it's a negative, I'm going to go in the clockwise direction. So I'm going to go down from here. I want to go 100 degrees. I'll estimate. I know that this is 90 degrees because that's the right angle. So I'm going to go a little bit past there. Okay, let's see if I go a little past 90, maybe around here. I have to draw a terminal side. And I have to draw an arrow showing that I went in the negative direction. Okay, the next angle is going to be 400 degrees. And we're starting all in degrees so we can get used to it. Okay, standard position, vertex at 0, 0, start from the positive x-axis. Okay, let me think about this. Okay, it's positive, so it's definitely going to go counterclockwise. So I'm going to start going up from here. 360 degrees is a full circle. So let's consider this. I'm going to have to go all the way around. Now I'm going to have to go a little bit more. I'm going to have to go about 40 degrees more. So I want to go to about here, I'm estimating. This is my terminal side. I have to draw the terminal side, and I have to draw an arrow to show that I went around 360 degrees and I went around a little more. And you should be able to see how many times you have gone around. So if I went around 3 times, I should actually be able to see all 3 loops. Okay, now we're going to switch to radians. If there's no symbol next to your angle, you always assume it's in radians. Okay, so we're going to start in standard position as always. Vertex, initial side. We start here, this is 0 radians, just like it's 0 degrees. Now I'm going to use the facts that pi radians is half a circle, which means if I travel halfway around the circle, this is pi radians over here. Okay, so if I want to graph pi radians in standard position, I'm going to go in the positive direction. and my terminal side will end up at the pi. Okay, I drew my terminal side and I used my arrow to represent that it is going pi radians in its rotation. Okay, for E, 3 pi over 2. I assume it's radians because if there's no units indicated, it is radians. Okay, this is my initial side. Okay, this is 0. I know that this is pi over here. If that's 0 and that's pi, then halfway between 0 and pi must be pi over 2. Okay, now that I know how big 1 pi over 2 is, I should be able to travel 3 pi over 2s. Okay, let me think about this. Okay, from my initial side, 1 pi over 2, 2 pi over 2, 3 pi over 2. So I'm going to end right down here. I'm going to draw the terminal side, and I'm going to draw an arrow showing that I went in the positive direction. Let's keep going with the radians. Okay, F is 2 pi over 3. Okay, and we're going to kind of estimate again. We always start from 0. I know that this is pi over here. Let's see, I want to go 2/3 pi. So I want to go about 2/3 of the way to pi. So I'm going to estimate. If I go about 2/3 of the way to pi, that's going to be about here. Okay, I have to draw a terminal side in. As long as you have a reasonable guess, you end up in the correct quadrant, and it's not crazily spaced. It's a good enough guess. Okay, for G, 7 pi over 4 radians. Okay, and again, I'm kind of using my estimating skills to guess this. I know that this is 0. I know that this is pi. And I actually also know that this is pi over 2. Okay, I want to go 7 pi over 4. So I want to think about how big 1 pi over 4 is. Okay, if this is pi, if I divide this into 4, okay, then realistically, this would actually be pi over 4 around here. This would be 2 pi over 4. This would be 3 pi over 4. This would be 4 pi over 4, which makes sense because this is pi. I want to keep going down on the 4, so let me imagine that these continued. Okay, let me draw this. Okay, so I want to go 7 pi over 4. So from the initial side, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Okay, if I want to see if I think about this, if I went one more, I would be at 8 pi over 4, which is 2 pi, which is a complete revolution. So that is reasonable, a reasonable estimate. Okay, H, negative 5 pi over 6. Always start from the initial side. Negative means I'm going to head kind of downwards. Let's see, I want to go 5 pi over 6s. Let me think. I know that this is going to be pi over here, and if I go backwards, that's going to be negative pi. So I kind of want to guesstimate about how far I'm going to go. So I'm going to try to divide this area into 6. 3, 4. Okay, so I divided each of the halves into 3, so now I have 6 of them. You don't need to divide it up every time. You just need, once you get better at these, you will be able to estimate about where it's going to go. Okay, so in the negative direction, I went 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, which is about here. If I had gone one more space, I would have gone 6 pi over 6, which goes to negative pi, which is very reasonable. Okay, one more. Okay, negative 5 pi over 2. Let me start from my initial side. Let's see. I know that pi over 2 is up here, so then negative pi over 2 must be down here. Okay, so I'm going to count negative 5 pi over 2. So this is negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2, negative 5 pi over 2. Okay, and I should be able to see how far you've traveled around or how many times you travel around, and there should be a terminal side marked wherever you end up. Okay, the next word is coterminal angles. Coterminal angles mean they have the same initial and terminal sides. They're coterminal, they end in the same place. We're going to start in the same place because we're going to assume they're all in standard form. Okay, when you understand the meaning of it, you can get the answer without showing work, but because I know some of you like to have work to see, well, I will show you how to get it using kind of like formulas and things. Okay, I'm first going to graph 30 degrees. Standard position, 30 degrees, probably around here. That's 30 degrees. Seems reasonable. I want to draw another coterminal angle so that it still starts at the same initial side and it still ends at the same terminal side, but it could be going a different way to get there. So one coterminal possibility could be, I start here, I go all the way around, but I still end up at the same place. That's an example of a coterminal angle. Okay, that was a positive coterminal angle because I started going up. If you're a person who likes formulas, what did I do? I did 30 degrees, plus I went an extra loop around. So the blue angle actually represents 390 degrees, which makes sense because I went a full 360 and then I went 30 more. You would not have to show work because for visual people, it's easier for that. They can easily visualize this scenario. Okay. If I wanted to find another positive coterminal angle, I could add 360 degrees as many times as I want. I could go around 20 times and then go 30 more degrees. So maybe if I wanted to go around 2 times, I could loop 2 times, 360 degrees, and then I could go 30 more. So 750 degrees would also be coterminal. Okay, now if I want a negative coterminal angle, if you're good at visualizing this, you don't need to show work. Okay, to visualize this, I want to start at the same initial side, but instead of going up, I'm going to head down. So I'm going to go this way, but I still want to have the same terminal side. So I could just stop when I get here. Okay, if you just look at that, you're like, oh, I went in the negative direction. I stopped 30 degrees short, so that puts me at negative 330 degrees. You can just write negative 330 degrees because for visual people, that's how they see it. They're filling in the gaps. If you like formulas, I could also say 30 degrees minus 360 degrees gives me negative 330 degrees. Make sure you put the degree symbol, otherwise we're talking about radians. Okay, just like with the positive ones, I could subtract 360 a million times if I would like to. That's just a lot of work. But so negative 690 degrees is another negative coterminal angle. I could add or subtract 360 degrees as many times as I want to get an angle that I am happy with, because sometimes some of them are more convenient than others. Okay, now doing coterminal angles with degrees is quite intuitive for many of you, but we use radians most of the time in this chapter. So I'm going to do the same thing with radians. When you kind of start to visualize it better, you will do this in your head, and that'll be fine. Okay, let me think. 7 pi over 6. Okay, 6 pi over 6 is pi. So 6 pi over 6, and then I'm going to go 1 more pi over 6. So I'm going to end up somewhere over here. And I'm just estimating to get close. Okay, to get a coterminal angle to this angle, I could do it just like I did on the degrees. I could start at the same initial side. I could loop around. Let me change colors. I could do a full loop or a couple loops, and then I could come back to the same terminal side. This is coterminal because they share a terminal side. And then you could kind of think in your head, convert everything to 6, 12 pi over 6 plus 7 more pi over 6s. Now I'm at 19 pi over 6. If you like to just have a formula, I'm doing 7 pi over 6 and I'm going a full extra loop. An extra loop in radians is 2 pi. Okay, so I do need a common denominator though. So 2 pi is really 12 pi over 6. So 19 pi over 6 is one of many positive coterminal angles. Okay, say I wanted a negative one. I want to start here and I want to go backwards. I want to get a negative answer. Well, some people think in their head, well, that's 7 pi over 6, so if I meet it backwards, it must be 5 pi over 6 because it has to make 12 pi over 6. If you do it like that, you're welcome to do it. Again, you could also start with the angle and you could go backwards until you get a negative angle you're happy with. Okay, I still need a common denominator. Okay, right now we're doing this kind of randomly, but there will be times when coterminal angles will give us just as good answers, but we can find a number that is better to work with in that case. Okay, here we go. Next words, complementary and supplementary angles. You did these in geometry or maybe even in middle school. Complementary angles add up to pi over 2 radians. That was like the 90 degrees. Supplementary angles add up to pi radians or 180 degrees. For them to be complementary or supplementary, it must be a positive answer. It is possible that not every number has a complement or a supplement. Visually, if you think about this, for these to be complementary, something like that, they have to make some kind of right angle or a pi over 2 angle. For them to be add up to pi, looks something like some kind of linear pair situation. Okay, I'm going to find the complement and the supplement of pi over 3. I'm going to do it by calculating it and by drawing it to appeal to the visual learners and the computational learners in this class. Okay, complementary must add up to pi over 2, so let's do pi over 2 minus pi over 3 to see what's left for the complementary angle. I need a common denominator. Let's make them both 6. So 3 pi over 6 minus 2 pi over 6 equals pi over 6. So it does have a complement. It is pi over 6. If the initial angle is higher than pi over 2, then it's not going to have a complement. Because if it already adds up to 100 degrees, you can't have another angle that adds up to 90 degrees because the answer must be positive. So if I had gotten a negative solution, it would have been no complement. Okay, if you are a visual person, okay, let's look at this. I need them to add up to pi over 2. Where is pi over 3? Pi over 3 is about this big. Oh, sorry about my ugly picture. If you can kind of visualize how much more do I need to get to pi over 2? It's half of pi over 3. That would make it pi over 6. I am okay with you visualizing it. There are times when it will be easier. Once you know the unit circle, it will be easier. And there are times when you would rather just do it the long way. Okay, let's do the supplement. Supplement adds up to pi or makes half a circle. Okay, if you like formulas, pi minus pi over 3. Let's make these both over 3. 2 pi over 3. Can't have a negative answer. If you get a negative answer, then there is in fact no supplement. Okay, visually, where is pi over 3? Pi over 3 is here. Okay, how much more do I need to finish my half circle? I need 2 pi over 3, 3 pi over 3, so I need 2 more pi's over 3's in order to get to my half circle. That's another good way to find the missing supplement. Okay, the last thing we're going to do is convert radians to degrees and vice versa. The main thing you just need to remember is that pi radians is half a circle, so pi radians is the exact same thing as 180 degrees, so I can use that ratio to find whichever units I'm trying to find. Okay, so for this example, we're going to convert them to radians. They are given in degrees. For them to be in degrees, there has to be a degrees sign. Otherwise, we assume it's radians because radians don't have a symbol. Okay, now let me think. I know that pi radians is 180 degrees. I want the 180 degrees to cancel. I want the pi to be in my answer. Since I want my answer to be in radians, I put the radians at the top. I put the degrees at the bottom so that the degrees symbol will cancel out. Okay, so if I do it this way, then the little degree symbol cancels out, which is exactly what I want to do. This is just like what you do in chemistry or some science. I think it's chemistry. Okay, let me see. I get 420 pi over 180. I'm going to simplify this using my magical brain. Cancel the zeros for sure. Let me see. I could divide by 6 on the numerator and denominator. So I will get 7 pi over 3, which is a great answer for radians. B, I'm going to do the same thing. It is in degrees. I want to convert it to radians. Okay, let's see. I want the degrees to cancel, so I put them on the bottom. I want the radians to stay, so I put them on the top. The little degree symbol will cancel if I do this correctly. Okay, Let's see if we can simplify this fraction. Negative 135 degrees. Degrees cancel. Let's see, if I divide this by 5, that's still not good enough. Let's divide it by 9. Okay, that looks better. And I can also imagine the graph of negative 135 degrees. That would be in quadrant 3. And the graph of negative 3 pi over 4 would also be in quadrant 3, which helps me realize I did it correctly. Okay, the very last example is converting 2 degrees from radians. Okay, so pi over 9 has no units indicated, so this is in radians. Because I want my answer to be in degrees, I put the degrees at the top. 180 degrees is equal to pi radians. Okay, the nice thing is that these little pi's, in this case, they cancel. Okay, so now I do have 180 degrees. I have degrees in my answer now because they didn't cancel, they appeared. So that's 20 degrees, which seems okay because pi over 9 is a pretty small little radian. Okay, I'm gonna do the same thing for the next one. I want my answer to be in degrees, so I put the degrees at the top. 180 degrees corresponds to pi radians. Okay, the pi's happen to cancel again. Okay, now the 180 over 3, I'm going to simplify it before I try to divide. 183, that would go down to 60. So now I have 5 times 60, which is 300 degrees. Okay, last one. No units, so we're talking, these are in radians. I want them to be in degrees, so I put 100 degrees, 180 degrees over pi radians. Okay, nothing cancels, so let's just multiply this out. Negative 360 degrees over pi. Okay, that's how many degrees. Negative 2 represents, if you wanted an approximation, it would go in your calculator. I will want exact answers. As you know, WebAssign sometimes likes decimals.